Well, coming up, if you ever see a piece of furniture suspended off a building and wonder why it doesn't fall, turns out there's a simple principle of science behind it.
Yeah, you got it. I'll be back with a new Mad Science helper to explain how this experiment works. Now, talking mad science, everybody deserves a day off once in a while, right? We gave Ryan the day off. We'll give Christopher Byrne the day off. Today we've got a guest coming in. His name is Mark, all the way from Kishwaukee College. Take a look. We have given Christopher Byrne the day off. We brought in a relief pitcher today. His name is Mark Schwendau. Thanks for coming in.
Thanks for having me on.
He is from Kishwaukee College. He is the technology instructor down there of the CAD department, which stands for Computer-Aided Design. Now, every day I sit here in the Weather Center trying to predict what's going to happen. We've got a truss roof over my head that keeps all of our computers dry. You have kind of an experiment that corresponds to how the truss roof works. Explain.
Correct. Well, this is actually a principle of physics. It's called static equilibrium. And the way truss roofs shift all the weight over our heads to the walls, the outside walls, is by principles of physics and static equilibrium. So today what I've got for us is a real simple concoction of a wire, little cheap ruler from the hardware store, the drugstore, and then a hammer, a claw hammer. And what we're going to do here is suspend this out over the edge of this table in space. And there's three forces going on here. If I push on you, that's an applied force. So what we've got here is we've got a hammer handle applying force to the ruler here. We've got the ruler itself applying force to the top of this countertop, and then gravity trying to pull the whole thing down. So it makes like a triangular type figure, and that's what keeps it suspended in space.
Ah, yeah. So if they kind of zoom in on that, you can kind of see that triangle that it starts to, what he's talking about right there. Typically, you would think that hammer is going to take that ruler down in an instant.
One would think. And it's about over 2 pounds that's suspended there in space.
And that's called static equilibrium?
Right. It's three forces in opposition together so that they remain stagnant.
Very, very cool. You would think it was magic.
Yeah.
You got a little tricks up your sleeve. I like it, Mark. Now, one thing to remind the kids at home, if you are going to do this, I'm pretty sure Mom wouldn't like you doing it over the kitchen counter or the tile on the floor, because in case the hammer falls the first time you're trying to do it, you might ding up the floor with the hammer. So do it over carpet or a soft surface.
The floors and the toes, we want to, of course, obey safety so that people don't hurt themselves.
Oh, for sure. I have 10 toes right now, and I'd like to keep it that way.
That's right. And no dings in the hardwood floors, you know.
Excellent. Thanks a lot, Mark. I wanted to quickly mention 40th anniversary for Kishwaukee College.
Yes, we're very proud of that. We've been here since '68, and I teach in the CAD technology program there, and we're very proud of our website there.
That's excellent. Thanks for coming in today. Join us every Monday for the latest Mad Science experiment. Big thanks once again to Mark for driving all the way out here to do that. But don't worry, I got Christopher. He's going to be waking up. We'll get him back into the swing of things for next Monday.
That was very cool. Does it matter? I'm assuming it matters specifically where that hammer is on the ruler.
Yeah, as long as it pushes up against the ruler, it's got that upward force so that it should suspend and stay over and kind of hovering above the ground, so to speak.
Well, maybe Ryan Cummings is watching and he'll try this one out at home.
Oh, man. Yeah, he'll probably lose a toe trying to do that one.
Well, we do have to take a break, but we'll be right back with news from around the country.